In this video, we're going to look at one last example of solving problems using Newton's second law and another example involving vertical acceleration. So in this case, we have a rocket launcher, or not a rocket launcher, a bottle rocket, which is a type of firework that launches straight up into the air. The 0.48 kilogram rocket was launched with an upward thrust of 25.0 newtons. What is the rocket's acceleration in this moment? So we draw a picture to analyze forces, and then we identify the forces that are acting on the rocket. So we always have the force of gravity on Earth. And we also, in this case, have an upward thrust force or applied force that's pushing the rocket upwards. And I'm thinking that the applied force here is going to be greater than the gravitational force. So there are no horizontal forces in this case, so there's no net force in the horizontal direction. The vertical net force is going to be these two vertical forces added together, so that's the applied force plus the gravitational force. So some of the information we're given about the rocket, we know its mass from this information right here. It says 0.48 kilograms. Anytime you see kilograms, you know that's a mass. And then we have a newtons over here, so that's going to be a force. What kind of force is it? It's the upward thrust force. So the applied force that we've named the applied force is 25.0 newtons. Force is a vector, and so we have to make sure we include the direction. In this case, it's going up. The applied force is going up, and so we write 25.0 newtons. Now, before we move on to find the acceleration of the rocket, which is the unknown, we remember from before the acceleration of an object is going to be the net force divided by the mass. In this case, the net force is the applied force of the rocket's thrust plus the gravity acting on the rocket, the force of gravity, or the weight of the rocket. So to really solve this equation, I'm skipping ahead a little bit, we need to know the weight of the rocket. So can we find that information? The answer is yes, we can, because if you recall, the weight of an object is equal to the mass times the acceleration due to gravity. So that's 0.48 times negative 9.81. So I put that into my calculator, 0.48 times 9.81, negative 9.81, and we get 4.7. So negative 4.7 newtons is the weight of the rocket. So I did it pretty quickly here, but I did it more worked out in a previous example. But the weight of an object can always be found by taking the mass and multiplying by negative 9.81. So now that we've done that, we can go ahead to the substitute step because we have all of the pieces that we need. So I'm going to be adding the applied force and the gravitational force. The applied force was a positive 25.0 newtons. And then I'm going to add my weight, which was a negative 4.7 newtons. And then the mass of the rocket is 0.48 kilograms. So I'm going to do some addition up here. Really, it's subtraction because it's 25 plus a negative 4.7. So that gives me 20.3. Positive 20.3 newtons is our net force. And divide that by 0.48 kilograms. Put that in my calculator again, and I get an acceleration of about 42 meters per second per second. So it's a pretty fast acceleration upwards, and it makes sense because the rocket's going pretty quick. It's accelerating very quickly. So that's all I've got for you in this video. Remember, confusion is the sweat of learning.